For example number 4, we're going to use the rational zeros theorem to find the rational zeros of the polynomial. So we're going to use the rational zero theorem to find the rational zeros of f of x, which is equal to 2x cubed plus x squared minus 4x plus 1. Now the rational zero theorem tells us that if p over q is a zero of that function, then p is a factor of 1 and q is a factor of 2. So we can see here that p represents the constant term, which is 1, and we can see that q represents the factor of the leading coefficient, which is 2. So what are all the factors of 1? Well, it's plus or minus 1. What are all the factors of 2? Well, it's plus or minus 1 and plus or minus 2. So the possible values for p over q are then plus or minus 1 and plus or minus 1/2. And these are the possible rational zeros for the function. And the reason why it's possible is because we need to find out whether they are a rational zero or not of the function. And we can determine which of the possible zeros are actual zeros by substituting each one of these values for x into the function. So if we take -1 and plug it into the function, so we're going to have 2 times -1 cubed plus -1 squared minus 4 times -1 plus 1. When we follow the order of operations, we get a value of 4. So that means the remainder is 4. And if the remainder is 4, then it's not a factor, it's not a rational zero. The second one, we're going to look at positive 1. So f of 1 is going to equal 2 times 1 to the third power plus 1 squared minus 4 times 1 plus 1, which is equal to 0. I put a check mark there because it equals 0. That means that it has a remainder of 0, so we can say that 1 is a factor or a rational zero. Now, if we try -1/2, if we plug in -1/2 for each value of x, then we end up getting a value of 3. So the remainder is 3. And since we get a remainder of 3, it's not a rational zero. And for 4, the last one, which is positive 1/2, if we plug that into the function, we get a remainder of -1/2. So again, because we do not get 0, it's not a zero of that function. So of those, -1, -1/2, and 1/2 all had remainders, so therefore they are not zeros of the function. However, 1 is the only rational zero of the function.